All right, so let's walk through how to graph a quadratic when it's in vertex form. So the vertex form is just what you see here. Can help with those H's and K's ring a bell as far as we learn from absolute value graphs. And much like that, a lot of the same values and implications are true, as in when A is positive, your prop is going to be opening up, so looking like this nice smooth U. And in turn, your vertex will be your lowest point. And then the y-coordinate of your vertex is called the minimum. So the vertex itself is an x comma y point, whereas just the y value is determined to be the minimum. When A is negative, again, you have your upside down parabola, so the parabola opens down. Again, your vertex is your highest point in this case, and the y-coordinate of the vertex is then considered to be the maximum. Right, so the vertex is, x comma y, and just the y in this case is considered the maximum. It also impacts both how wide and how narrow the graph is, also like it did with absolute values. So if the absolute value of A is greater than 1, your probably is going to be a bit more narrow or steeper, if you want to view it that way, than whatever the parent or the basic version would look like. So in my three graphs here, again, I made sure to keep them both the -1 inside the parentheses and the +1 after. That never changed. So the H and K values were never the same. Were the same rather, but I kept changing the A value. Again, here A is 1. And then once we made it larger than 1, simply more narrow. Again, you're thinking about the absolute value. Again, so the absolute value of this is indeed larger than 1. So again, that's why this green graph is more narrow than the other. Again, if you remember, the way of wording making it narrow is called vertically stretching. And that's the case again when the absolute value of A is greater than 1. And the reverse was true when the absolute value of A is less than 1, which actually is to say between 0 and 1. So just like before, I'm going to reference that this initial one has A being 1, whereas this has A being 1/3. Again, the absolute value of 1/3 is a third, which is definitely less than 1. And hopefully you can see the purple graph is definitely wider than this one. So this is -3/4. Again, we're looking at the absolute value of that, which makes it a +3/4. +3/4 is definitely between 0 and 1. And again, hopefully you can know this black graph is wider than the red one. Again, it's opening down because A is negative, but as far as how wide or how narrow it is, that's based on the absolute value of the A value. If you remember, again, making it wider is called vertically shrinking it. And as you may have noted, making it more narrow is called vertically stretching. As far as the axis symmetry, you can also just pluck right out of the equation. It's always x equals h, and the vertex is always h comma k. Again, also just like before. And the axis symmetry, again, acts kind of like our mirror. It's a nice reflecting pool, so to speak. When it comes to graphing, we're going to go ahead and plot our vertex and then draw the axis symmetry through the vertex. That said, if we know A is positive, that means our graph will be opening up. So you want to make your axis symmetry go up from the vertex. Where if A is negative, you're going to be graphing it or opening down. So it makes sense to make your axis symmetry go down or below the vertex. And lastly, as far as graphing, we're generally going to make tables that contain 5 points, with our vertex being one of those 5. And ideally, the vertex is right in the middle of the graph. So in turn, we're going to put it right in the middle of our table and then pick both 2 numbers before and 2 numbers after. A lot of time using x equals 0 is helpful because, again, x being 0 is convenient as far as the calculations, but also it can help you find the y-intercept. We can also sometimes use the axis symmetry to find its mirror image. So here's an example of what I'm talking about. This equation, hopefully you can somewhat quickly tell that A is 1, H is 5, and K is 1, meaning the vertex has to be 5, 1. I put that right in the middle of the table. You can do whatever you want. It just helps to make it balance. So I think it probably makes the most sense just to count, as in go in order. We got 3 and 4 come before 5, in turn 6 and 7 will come right after 5. That should also mean when we plug 4 in the equation and get a number, 6 should be the exact same result because, again, those are mirror images of one another. So if we try the calculation, last time I checked, 4 minus 5 is -1. -1 squared is 1. If you add 1, you get 2. That should be the same result if we plug in 6. 6 minus 5 is 1. 1 squared is 1. Plus 1 is indeed 2. Same thing would happen if you plugged in 3 and 7. You would get a different number than probably 4 and 6 got you, but both 3 and 7 should get you the same result. And that's how it goes.